3. We're going to start with number 7. It's a math problem just to get us going. And we're going to solve for x. So for number 7, it says solve for x based on the given information. And it says given angle A, fancy squiggly equal sign, which means congruent, to angle BDA. So if I actually look at my picture, in geometry, they like to give you a lot of extra information that you do not need. So if I look at angle A is right here. We know angle A is equal to 5x. And then we know it's congruent to BDA. If I look at my picture, if I start at B, I go to D and I follow to A, that's talking about this angle. That orange angle, the second angle, has nothing in that space. I know A is 5x. I know that this angle is missing some information. I know that they're congruent, so they're equal to each other. So does anybody think that they know maybe where I could move something to help me solve this problem? Yeah. So she said that I can move the 3x plus 30. The 3x plus 30 is over here, technically, in this angle on this side. But I can take 3x plus 30 and bring it to the other side of the intersection because they're vertical angles. So vertical angles are congruent. So if I know 3x plus 30 is here and I cross over that intersection, that is also 3x plus 30 because of vertical angles. The whole point of this is to make an equation to solve for x. If I know angle A and BDA are congruent, what's an equation I could set up to solve for x? 5x equals 3x plus 30. And then I have to pick what I'm going to move across my equal sign. This is a 2-step equation. What would combine with a 5x that's over here? 30 or 3x? 3x. It's positive, so I'm using subtraction, property of equality, to move it across. We don't have to like write out the reason, but that is actually the reason why we're doing it, because it's positive, so I'm technically making it negative. So I'm using subtraction to get rid of it. So 5 minus 3 is 2x equals 30 that I can bring down. And then the last step is to do what? Divide. So I'm going to divide by 2 to both sides. And just like yesterday, that is technically division, property of equality. So x is equal to 15. So that's really like an example for all the rest of the math problems that you're going to do. Let's do the proofs together. We'll go down to number 8 since it's right under number 7. We'll do number 8 first. For yesterday's proofs, they were completely blank. We had to literally fill them in from scratch. You will never have to do that on your EOC. Thank goodness. There has to be at least a maximum of 3 blanks. If you look at this problem, I have 1, 2, 3, 4, 5, 6. I have 6 blanks, but the word bank is provided. On your EOC, it'll be like a little arrow and a drop-down box, and like you'll have to just pick the best option with a max of 3 blanks. So let's look at what we got. We have the first blank that's empty. Yesterday, what we talked about on proofs was the left side of the proof is always going to be the math area. The right side is always going to be the word area. So this is like your justifications, multiplication, division, property of equality, your addition, property of equality, your subtraction, property of equality. So all of your reasons, your words are going to go on the reason side, the right side. The math is going to stay on the left side. So if you look, I have 1, 2, 3 words. I also have 3 blanks on the reason side, and I have 3 math looking things that are going to go on the left side for the statements. So from yesterday, what should the first one always be? The given. So if I look at the actual statement, it says given angle 1 is congruent to angle 7. And it literally says the reason is given. I'm going to fill in the given, which is angle 1 is congruent to angle 7. And I'm going to cross that out in my word bank because I can use process of elimination. So 1 and 7 are congruent. So if I look at my picture, 1 and 7 are congruent because that's what's given. So I have these ones that are the same angle measure. If I look at the next blank, I have something and it says vertical angles are congruent. I only have two math options down here. I have 6 is congruent to 7, and I have 1, 6, and 7 are all equal to each other. So if I look at 1, 6, and 7, 1, 6, and 7 are not in the same intersection. They're 3 separate angles. They're saying that they're all congruent. And then the other option is 6 and 7 are congruent. So which one would represent a pair of linear or vertical angles? 6 and 7. 6 and 7 are a pair of vertical angles. They're across from the intersection together. So I'm going to put angle 6 is congruent to angle 7 because 6 and 7 are the only vertical angle options that I have. And then I can kind of use process of elimination. The last math type given word bank is going to go in 4. So I could put measure of angle 1 equals the measure of angle 6, which equals the measure of angle 7 in number 4, because this is my math side, is the statements. You might need to write a little small. Sorry, I don't know why it came out so small. Okay. So once we have that written in, we have to go back and we're going to fill in our reasons that carried us to the next step. So if I start from the beginning, I have 1 and 7 are congruent. That's given. I have 6 and 7 that are congruent because they are vertical angles. 6 and 7 are vertical. And then I have 1 and 6 that are congruent. 1 and 6 are technically corresponding angles. But if I look at my answer choices, it doesn't say anything about corresponding angles. So I have to use one of the things that are provided to me to fill in the blanks. So if I look at my options, I have transitive property of congruence, I have substitution property of equality, and I have linear pairs theorem. So if I look at 1 and 6, are 1 and 6 a linear pair? Are those angles going to add to make 180? No, they're both the same. They're both small. They're both acute. Two acute angles will never add to make 180. So that's not the option. And then I have substitution and I have transitive. So if I look at my options from the beginning, it says 1 and 7 are congruent. Then it says 6 and 7 are congruent. And then it just jumps to 1 and 6. It's actually removing that middle man. So if I look, it says 1, 7, 6, 7, and 7 is gone. And now I can say 1 and 6 are congruent. That's the new thing that we talked about. It's getting rid of, I don't want to like cross this out, but it's getting rid of the middleman. So this is transitive property because it's saying now that I can say 1 and 6 are congruent to each other. So we'll say transitive property of congruence. Hey. Property of congruence. And then we have 1, 6, and 7 are congruent because definition of congruent angles. And then I have the measure of angle 1 and the measure of angle 2 equal to 180 degrees. If I look at 1 and 2, 1 and 2 are next to each other versus the last option, 6 and 2 are not next to each other. If they're next to each other and they add to make 180, are they a linear pair? Or should I say substitution property? If they're directly next to each other, they're adjacent. Linear pair. That's all. So this one's going to be linear pairs because they are directly next to each other. 1 and 2 are next to each other. They add to make 180. So I'll put linear pairs theorem. I always spelled theorem wrong. Theorem. And then the last one is substitution because they're saying that I can substitute once I know that these are like all congruent to each other. I can replace 1 and 6 because I know 1 and 6 are congruent. And that's basically saying 6 and 2 also add to make 180, but they're still not a linear pair because they're not directly next to each other. Last one we're gonna fill out is the other proof, because I don't want you to have to do proofs by yourself yet. So we're gonna go to number 3, and then we'll be done, and you guys can do the math part. So for number 3, same thing. I have a picture. Once again, the statements or the math should really be on the right side or the left side. My words should be really on the right side. So based on what I have, it says angle WZX is congruent or equal to WZV. These are two congruent angles. I know that because it is given. The first reason should always be given. And then the next part says WZX and WZV are a linear pair. So they're telling me they're a linear pair. So let me look at my options for my reasons. Remember, the reasons should always be words. So I have 2 reasons. I have linear pairs theorem, and I have definition of linear pairs. If it's saying that they are a linear pair, would that be the definition or would that be the theorem of linear pairs? The definition, because it's in words. So since they're writing out in words over here, that is automatically the definition. So we're going to put definition of linear pairs. I'm going to cross that out. Then using those same angles, it says the measure. So now we're talking about numbers because it says the measure of angle WZX, same thing, WZX, this angle, plus WZV, add to make 180. So they're adding to make 180. What is the reason that they add to make 180? Linear pairs theorem. So the only other word option is linear pairs theorem. The theorem is where it's literally an equation adding to make 180. The definition is in words saying that they're a linear pair. So this is linear pairs theorem. That's okay. So we got those 2. And now your statements are always your math part. We have 2 options. We have to figure out which one should go first. You have 50-50 chance. So I'm talking about linear pairs. So the next one says supplementary angles are right angles. Supplementary congruent, I skipped the word. Supplementary congruent angles are right angles. Supplementary, remember this S turns into an 8. So they technically are adding to make 180. So I have to determine which one would best represent that. They're saying that they're congruent. And if you think about this, it's 2 angles that are congruent to each other that have to add to make 180. 2 angles that are congruent to each other that are right angles add to make 180 are 2 90-degree angles. So should I say that they're perpendicular to each other, or should I say that the measure of this angle and the measure of this angle both equal to 90? Both equal to 90. So that's telling me each one of these angles is 90 degrees. Together, they form a straight line, which is 180. And then the last one is definition of perpendicular lines. So we're going to say WY is perpendicular to VX. Perpendicular, this upside down capital T, is the fancy math term for perpendicular. Perpendicular means 90 degrees. So anytime you see an upside down capital T, it's literally 2 lines that are intersecting, forming a 90-degree angle, because a T is technically a 90-degree angle. The rest of these are just math problems. That's a review of like chapter 1 and chapter 2, kind of, well, chapter 2 really. So you can work on this. What's up? Yeah, it's the past. If you need to finish cycle 1 or submit cycle 1 or start cycle 1, you could also do that today and do this paper tomorrow or do cycle 1 tomorrow. But you need to get on there and make sure you submit it. Tomorrow's like the last day. So if you haven't went on there and finished it. Yeah, it's on, you should be able to see it, but I can pull it up if you want me to. Oh. Does anybody need to borrow a computer for Cycle 1? Does I have a computer?